In this video, I'm going to take you through nomenclature of cycloalkanes. In our previous classes, we learned about alkanes, and in this video our focus is on cycloalkanes. Cycloalkanes is a group of alkanes and they are cyclic. That is why we have the word cyclo. So they are cyclic in manner. They form this shape where each vertex is a carbon. So cycloalkanes, they are a group of alkanes which has a cyclic structure. In this video, we are going to learn how to name various cycloalkanes. Generally, cycloalkanes are represented as CnH2n. So as you know, if you have your first carbon, you are going to have CH2, but cycloalkane you can't have one carbon forming a cycle. To form a cycle, you need at least 3. So you have to start from C3H6, right? C3H6 is going to be cyclopropane. So the name of cycloalkanes follow the manner you bring cyclo, then depending on the number of carbons, it's going to be propane, butane, pentane, and in that order. To form a cyclic structure, you need 3 carbons at least. So to start with our naming, we know what we call alkyl groups from our classes in nomenclature of alkanes. Here we have what we call cycloalkyls. Cycloalkyl. What this means is that you can have a straight chain. Let me give you the skeletal structure. You can have a straight chain alkane with a branch chain being an alkyl group, which is a cycloalkane. So you can have a propane somewhere here, and this is going to be a cyclopropyl. So cyclopropyl. That is the manner we use, cyclopropyl or cyclopropyl. So a cyclic alkane or a cycloalkane can be a substituent, hence will be an alkyl group. For that reason, you call it a cyclo, then you add butyl, pentyl, and in that manner. These are basic stuff you should know. Then with the rules for naming, the lowest carbon number is given to the longest carbon chain and the substituent. So if you have substituent on your longest carbon chain, look, the lowest carbon number is given to the substituent, and that is the rule. So we are going to solve few examples for you to understand cycloalkyls and also cycloalkanes naming. So let's see our first structure. The first structure I'm going to take you through is this structure. So I'm giving you the open structure. So I have CH3 here. Then I have CH3 also here. Now the rule is, how do I name this compound? To name this compound, you need to count the number of carbons. We have 1 carbon here, another carbon here, another one here. So 1, 2, 3, 4, 5, 6. 6 carbons. Once we have 6 carbons, we have to identify the substituent. We have one substituent here, another substituent here. Then we have to number the carbons and give the appropriate substituent the appropriate numbers. For that reason, you have to give the lowest possible number to the substituent. That is to the carbon which is having the substituent. So we can start from here. So let's see. We are having carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. And it is a hexane, right? So you can start 1, 2, 3, 4, 5, 6. So this is just naming of this compound. You just need to number the carbons. So 1, 2, 3, 4, 5, 6. The reason why I started from this side is for me to get the lowest possible number for my substituent. So let's see. You have this methyl group being the number 1 and this being the number 3. So to name it is simply 1, 3 dash, because we have the same substituent, so the numbers will be grouped aside. So dash dimethyl, and 1, 2, 3, 4, 5, 6. So we say hexane, and that is how we name it. Now let's move to our second structure. So we have this structure. This is a skeletal structure of a straight chain. So let me give you. So we have this. So I'll have, yes, this is it. So there are how many carbons? 1, 2, 3, 4. 4 carbons. But there is a substituent here, which is a cycloalkane. Now, how do we go about naming this? As I said earlier, we take numbering which will have the lowest possible value. Starting from here, carbon 1, carbon 2, carbon 3, carbon 4. So 1, 2, 3, 4. Then starting from here, 1, 2, 3, 4. Meaning this will be appropriate. You have to start from this side. Starting from this side, I'm going to have 2. That is my substituent. So 4 carbons means that it is a butane. And my substituent here has 1, 2, 3 carbons, and that is going to be cyclopropyl because it has replaced one of its hydrogens with a bond in this structure. So it is cyclopropyl. So to name this, you have 2 cyclopropyl butane. Right, so this is how we go by it. Let's see our third structure. So I'm going to have this, this, this. So let me start once again. This way, this way, this way, this way, this way, this way, then this way. So I have one substituent here, CH3. I have another one here, CH2, CH3. To name this, how many carbons do we have? 1, 2, 3, 4, 5, 6, 7, 8. So this is an octane. I have 2 substituents. This is an ethyl substituent, which is an alkyl group, and this is methyl substituent. Now, in naming of organic compounds, the substituent comes in alphabetical order. Ethyl will come first before methyl. To number this, ethyl should have the lowest number. So I'll start from 1, 2, 3, 4, 5, 6, 7, 8. Right? For that reason, I'll have 1 ethyl, 3 methyl, and it is an hot octane. And this is a cycloalkane, so methyl cyclooctane. And that is simply how we name organic compound. 1 ethyl, 3 methyl, cyclooctane. Now let's move to the next structure. Number 4, I have this structure. I have Br here, and I have H3C, or a methyl group. So this is a cycloalkane with 4 carbons, 1, 2, 3, 4. Therefore, butane comes in mind. So once we have butane, we come to the substituents. We have a bromine here, we have a butyl group here. So bromide and ethyl group. This is an organic substituent, this is inorganic substituent. Always inorganic comes first before organic. And in this case, I'm going to have a numbering that will give me the lowest possible number for the starting. So we'll have 1, 2, 3, 4. So that is 1 bromo, 3 methyl, and it is 4 cyclobutane. Now let's see. I have another one here. I have this, this, this. 1, 2, 3, 4, 5, 6, 7. 7 carbons. I have a substituent here, CH2, CH3. I have one here, CH2, CH3. Then I have finally CH2, CH3. So I'm having 3 substituents which are all ethyl groups. They are all alkyl groups which are ethyl. And I'm to name this. I have 1, 2, 3, 4, 5, 6, 7 carbons. And that is a heptane. So let's start. So this will be 1, 2, 3, 4. Right? If I should start from this side. So 1, 2, 3, 4, 5, 6, 7. So if I should have started from this side, I'll have 1, 2, 3, 4, 5. And our naming is going to be invalid because starting from here will give this to be 1, this to be 2, and this to be 3. So I have 1, 2, 3, tri ethyl hot cycloheptane, since it is 7 carbons, as simple like that. Then let's see finally our last structure. So I have CH3 here, CH3 here, then I have Cl. So I have 1, 2, 3, 4, 5 structures. Sorry, 5 carbons. Then I have a substituent which is an inorganic chlorine, and I have 2 methyl substituents. So let me start naming. Since chlorine will be named first as chloro, inorganic substituents, I have 1, 2, 3, 4. If you start from here, get 1, 2, 3, where 4, 5, and that is not right. So 1, 2, 3, 4. So 1 chloro. Then you have 2 methyl, so it will be 2, comma, what? 2, 3, right? 2, comma, 3. Dimethyl cyclo, and it's 5, so pentane. And that is how to name cycloalkanes. This is the end of this class. Join me in the next class as we move through nomenclature of the various organic compounds.